Okay, so events that affect each other. So the outcome of one event affects the outcome of the second. Okay, so like I said, it's raining. Because it's raining, I wear a coat. Those are dependent events. So it works the same way. We're still multiplying fractions, but you have to be careful about your second fraction. Okay, so decide dependent or independent. Driving at night and falling asleep at the wheel. Okay, this one you could argue both ways, right? Isaac, why'd you say independent? Why do you think it's independent?
Because I don't know. I mean, people always. I don't know.
You don't
maybe,
have.
Maybe a dependent.
It's not just because it's nighttime that you might be falling asleep, right?
Yeah.
Okay. Ava, why did you say dependent? Okay, because at night you're tired. So maybe it being night affected that. So that they're not always super clear. And on this one, you could circle either one and you would be right. As long as you had a reason. Okay. So pick one on number one. Okay. Number two, visiting the zoo and seeing a giraffe. Am I gonna see a giraffe in my backyard? No, I had to go to the zoo to see the giraffe, so that one would be dependent.
Unless they smuggle one across the border.
You mean the ocean?
Yeah.
Okay, so independent or dependent? You're looking at the road and the next two cars that drive by are red. Does the first one being red make the second one be red? No, so it's independent. Okay, a coin is tossed twice. Does getting heads the first time make you get heads the second time?
No, I was.
No. Being dealt 4 aces in a hand of poker. Now, here's what's important. In poker, if I get the first ace, do I have to put it back and then draw a second one? No. So every time I take one out, it changes what I can draw next time. So in cards, this would be dependent because if I'm holding one of the aces, I have less of a chance to get an ace on the next draw.
Read that. I run back.
It's your birthday and it's windy. Independent, completely separate. You have a birthday in February, it might be windy, it might be freezing, it might be sunny and fine, and you're wearing shorts. Okay. Example 1. A bag has 10 marbles, 4 blue, 4 red, 2 green. We need to find the probability of drawing a green marble without replacing it. So whenever anytime it says without replacing, the fraction changes. So on the first draw, what is the probability of drawing the green marble? There's 10 marbles.
2 out of 10.
There's 2 green marbles. There's 2 out of 10. Okay, I'm not putting that green marble back. I'm keeping it. So now how many total marbles are there? 9. So if I want to draw the other green marble, there's 1 green marble left. 2 times 1.
2.
10 times 9. That reduces to 1 out of 45.
Told you.
Okay, we're starting over. We want to draw a red marble. What's the probability of drawing it red? 4 out of 10. Okay, now there's 9 marbles left. How many are green? 2.
2.
Okay, so 2 times 4.
8.
Over.
90.
And that reduces to 4 out of 45. Questions? Comments? Concerns? Nope, you got a backside. Flip it over. Okay. Number 2, you draw 2 cards from a deck. There's 52 cards if you don't know that. What's the probability of getting a king first? How many kings are in a deck? 4 out of 52. We're not putting that card back. How many cards are left? Okay. So how many jacks are there for me to draw the second time?
Oh, three.
Whoa, did we take a jack out?
No, it's four.
No, so there's still 4, right? 4 times 4 is 16. Who's got a calculator? 52 times 51. Isaac's on it. 2,652. We're not going to reduce that because that's a pretty big number. If you wanted to reduce this, you can grab a calculator, type 16, hit the ABC button, and then type 2,652. It'll reduce for you. This button right here, magic. Okay, part B. How many face cards are in the deck? There's king, queen, jack, and there's 4 of each of those. So there's 12. Okay, we're still not putting that card back, so it's 51 again. How many aces are there? 4. Okay, 12 times 4, 48. And we know 52 times 51 is 2,652. Part C, what's the probability of drawing an ace the first time? 4 out of 52. Now, if I'm keeping that, there's 51 cards left. How many aces are left? 3. 4 times 3 is 12 over 2,652. Okay, it's just multiplying fractions. We can handle this, right? Hopefully you're saying yes. Okay, let's look at this one. A vase contains 7 purple, 9 yellow, 12 pink. Randomly choose a flower from the vase. Then your friend randomly chooses a flower. You take them home, so you're not putting them back. What is the probability you draw a purple flower? How many purple flowers are there? 7. Add up the total. 7 plus 9 plus 12 is what? 28. Okay, then your friend is going to take one. How many are left now? 27. What's the probability that your friend chooses yellow? 9 out of 27. What's 7 times 9? 63. Somebody grab a calculator. 28 times 27. 756. Okay, so here's what I want you to do. There's only one problem left. You need to do this one on your own and then check your answer with me. There is a homework assignment. It's on Canvas, 9.6 practice. So you need to answer this, get it checked, do the homework. That's it for the day.
I feel like we should have got on.